Okay, so for question one, let's have a look. We've got a teacher is investigating the time taken to complete an aptitude test. The principal produced the table below of coded times for a random sample of 30 students. Use linear interpolation to estimate the median of the coded times. Okay, so first of all, I'm taking note that there's 30 students here. So the median of that is going to be 30 divided by 2, which will be at the 15th kind of one. You can, if you want to, you can do the whole add 1 divide by 2. Because I'm going median, I'm just going to just do 15 divided by 2. So here, say it doesn't matter which one you do here. So Q2, you'll still get the same points. So Q2 is equal to, now, if I know that it's the 15th person, there's 3 people here, and we've got 15 here. So the total between these two is 18. So I know it's not in this first one, but it must be in this second category. So the 15th person is in here. Now I've already used 3 people here. So I want to go another 12 to get to 15 into this category. So I'm actually going to do it using proportion here. I want to go 12 people into this out of the 15. So 12 out of 15 into this category, which is from 5 to 10. So this has a class width of 5, so 10 minus 5. I'm just checking here that it's 0 to 5 and then 5 to 10, so there's no times. I don't need to do any kind of update on the boundaries there, like 5.5 or whatever else. So it's just 0 to 5, 5 to 10, so everything's included. So this class width is 5. That'll tell me how far into this category. Now remember, we're trying to work out the time, and this started at 5, so we need to add on the previous kind of the 5 that we've already had, and that's part A. We just have to work that out now. So I do 12 divided by 5, by 15, sorry, times 5, and then plus 5. So that tells me it's 9. If you do use n plus 1 divided by 2, you'll get an answer of 9.16 recurring. So if you do, it would be then, it'll be 12.5 because you'd want the 15.5th person, and then 15.5 minus this 3 is 12.5. So the only thing that will change is this number at the top here will become 12.5. Part B, couple of ways of doing part B. You can use the calculator if you want, which I'll do in a second, or you can use the formula. So the formula itself is for the standard deviation that I'm going to use here. So standard deviation is equal to the square root of variance, and that formula is the sum of f x squared. It's actually called y in this one. I don't know why. Yeah, because it's the coded times, divided by the sum of f, and then minus the sum of what we've got here is going to be fx over sum of f all squared. So it's the mean of the squares minus the square of the mean, because this bit here is actually your mean. This is x bar. This is the square. So it's the mean of the squares. So I'm squaring the numbers, then divide by however they are. So the mean of the squares take away the mean squared. Bit of a mouthful. So when you put that in, you're going to get 5675 divided by 30 minus 355 divided by 30. So that's the mean squared, and then just simply square root that answer. So what's that going to give me? Let's put all this in at once. Once all squared. So it's 7.009 or 7.01. So how do you actually do it on your calculator? You can put the coded times into the calculator. So if you go menu and then into distributions to number 6, we want one variable, and then just put your numbers in here. I don't have the frequency on here itself, so you need to put that on. So you do shift menu, and then it's just on the next bit down, you go into statistics, and then frequency on. once you've got that, you can put those in. So you go down and you put each number in. So I want to put each of the coded time in these. And if you notice, the coded time itself is just a midpoint, isn't it? So we've got 2.5. What have we got here? So it's strange that they give us the midpoint here. If I'd have read the question properly, that would have been handy. And then I just want to put in those frequencies. So I've got 3, 15, 2, 9, and 1. So just check that they're all lined up. Once you've got that, click on Option, and then click on the one variable calculations. And then you can just pull everything off there. So I know X bar is 11.8. I know the standard deviation here is 7.009. If you did put in the sample one, 7.12, that is also accepted for this, but it should actually be the other one. It should be this one here, the sigma. Apart from that, that's all of that done. Part C then goes on to say that the teacher is told by the principal that he subtracted 15 from each of the class times and then divided by 2 to calculate the coded. So the coded was y. So I know here that y is equal to the original minus 15 divided by 2. In this case, I'm using x. Y is the coded one from the question. And I didn't do that in that formula, but I should have. For this, and we want to use this to unwind. So in other words, this implies that x is equal to 2y and then plus 15. This is kind of what's happened. Now, what you should remember is that your standard deviation is not affected if you add 15 to everything. So if you imagine all of your data on here, and let's say you kind of your standard deviation is kind of fixed on this data. If you add 15 to all of these, that box is going to stay the same. All it's doing is shifting down 15 along kind of the scale. It's not actually like that, but still, we're just shifting it. The mean, of course, will change. It will get added by 15, and it will also be affected by that multiple. The multiple will also affect the standard deviation. So they're the two things that I'm thinking about here. So the median, I said mean then a second, I meant median. The median itself is going to be 2 times the coded median, which was 9, plus 15, which is 33. And the actual standard deviation for x, this one was technically, this is for x, so this one here is for y. The standard deviation for x is going to be 2 lots of my actual one up here, which in this case is 7.009, whatever it was. 13615. So if I just put that in my calculator, I'll end up getting 14.02 when I round that to 2SF. That's it on there. So next up is D. The following year, the school has 25 certificates of achievement available. The teacher decides not to award a certificate to any student who takes 35 minutes or more to complete this test. The class has 60 students. Comment on whether or not he'll be able to actually award these, or she. I don't know. Let's have a look. Where are we? 35 minutes or more to complete there. What we could do here is we could notice the fact that the median is 33. So that's right in the middle. So it means that more than 50% of students will actually complete it in less than 35. So you could say for D, as 33, that's the median, is less than 35. So remember, that's the median time, 33 minutes, is less than 35 minutes. This implies that more than 30 students will complete in that time. Now, it's actually more than 30 students as well. I'll get onto that in just a second. So yeah, we've got more than 30 students are going to complete this. So that'll mean that he's not got enough certificates to fill. So there's a chance that all 25 will get used and then he'll need more. So that's what we want to comment on there. When I actually did this, I did it slightly different. I believe I tried to work out the actual coded time itself. So I was having a look at the times itself. So 35 minutes, if I want to kind of work backwards from that. So if 35 is my actual time, I'd put it back into here and work that out. So 35 minus 15 is 20. 20 divided by 2 is 10. So I'd be looking at how many students took longer than that. So in this case, it's 9, 10, 11, 12, and trying to work from there. And there are a few ways of kind of doing this. But it basically comes out to be 36 students. Let me just, is that right? Yeah. So it'd be 36 students that would actually need these, and you can do that kind of properly. Question 2, just clear my calculator back down. If you do want to see that previous question, by the way, just let me know, and I'll do it the other way. I'll get out of this. There we go. There are 108 students at college. Take a course of computing. Students in this course choose up to 3 options. Draw a Venn. So with a Venn, the trick to a Venn is always start in the middle. So the first thing I'm going to do is create my universal set. That's the box. And then noticing that I've got systems support, which I'm going to call S, developing software, which I'm going to call D, and networking, which I'm going to call N. So F is this circle here. I'm terrible at drawing these. I'm going to do that again. Let's try and find whereabouts I want them all to cross, probably around there. I'm going to get a big enough overlap on these, just so you can actually, you've got all the different overlaps. Okay, so the big thing here is always start in the middle and work outwards. So if you know what's going on in the middle, you can then try and figure out. So this is S, this is D, and this bottom one is networking. So D and S, the overlap between D and S, so that actually includes this middle. So that's why it's very, very important that you know what's in the actual middle itself. So that's going to be the first step here. So I'm looking at this and seeing that 4 take all 3, so that goes right in the middle. 35 take D and S, so 35 in total, so that 4 and 31 would make 35. That's D and S. Next up, I'm going to do the next one, which is network and developing. So that's N and D. That's 28. So 4 and 24 make 28. And lastly, 40 take S and N. So 40 minus 4 is 36. I know that 81 take networking on its own. So then I'll have to add these up. So 30, 40, 50, 60, 64 people there. There's 81 in total. So that leaves, oh, what have I just done? I've just forgotten my numbers. Oh, well, 30, 40, 50, 60, 64. So I need to get to 81 from 64, which you can tell is taking some time here. I believe it's 17. Finally, 36 plus 31 is going to be 67 plus this 4 is going to be 71 in systems, and I know there's 112. So 71 plus 42, 41. And then developing is 70. So I know this is 31 plus 24 is going to be 55, plus the 4 is 59. That leaves 11 here. Now, the big thing is I know there's 180 people. So if I add together everything in here, 41, actually, you know what? I'm going to do 112. So I know that's all of the S plus 11, 24, and 17. So I'm looking for fastest shortcut I can. That's 164. I want to do 180 minus that to get what goes on the outside. Hopefully you've already spotted 16. That just goes out here. So that's the remaining people that didn't choose any of these 3 things. That's completed Venn, but always starting inside, working outwards. Most common mistake I see is people assuming that this bit here, let's say, is 112, this bit's 70, this bit 81, and so forth. It doesn't make sense because there's only 180 students. So this is a great way of recording where you've got overlapping data and things that can happen at the same time. B, find the probability that the student takes none of the 3 extra options. Well, none, we've got 16 students. So B part 1, probability of none is going to be 16 out of 180, and I can just leave it like that. Or you can simplify it to 4 out of 45. Part 2 is networking only. So only networking is at 17. So n only is, let's just put that like that, just so you can see, is 17 out of 180, which will simplify. And finally, at B, students who take system support and networking are eligible to become technicians. System support and networking is everything here. So anyone that's in either of these two circles. So basically not that 11 and not that 16. It's important that you see that it's only systems and networking that are eligible here. So we need to add those together. So we need to figure out how many people do systems and, it's systems and networking, not or, systems and. So the only people that are eligible are inside this little bit here. They're the only ones that do both of these. So in terms of this, to do S and networking, then that means it's going to be out of 40. So 40 people. Then it goes on to say, given that the randomly chosen student is eligible to become a technician, find the probability that it takes all three options. So here, what we've got is technically we've got all three options, given, that's this line, that they take systems and networking. So the probability they take systems and networking, not probability, the number of them is 40. So this is out of 40. Now the number of people that take three options is only 4. So it's 4 out of 40. And that's that question done. Again, you can simplify that 1 out of 10. Question 3, binomial distribution. So part A, give a reason why binomial would be suitable. So there's 4 reasons why binomial is suitable. Independent events. So I'm not going to write these out in full, but independent events. So each spin is independent. It's got a fixed number of trials. Each trial has a fixed probability. Or finally, what's the last one? It is equal probability each time. So each probability is constant. So constant. Oh no, I've already done constant probability. What am I missing? Let's just have a look. Oh, 2 outcomes. So we're doing binomial. So it must have 2 outcomes. In this case, heads or tails. Part B, find the probability that T, so the number of tails is 5. So we know it's spun 6 times. Find the probability it's actually 5. You could do this manually if you want. I'm going to use the actual binomial in the calculator. So it's spun 6 times. The probability of getting a head or a tail in this case, is 0.5. And we want to know when is T equal to 5. Yeah. What I've actually got here. So the probability that T equals 5. Let's just have a look on here. Load up. There we go. So for this one, I want the PD because it's equal to variable. You can actually do list if you want. It's entirely to you. The list here, I'm going to show you the list in just a second. So I want 5. The number of spins is 6, and it was 0.5. So this gives me a probability of 0.09375. If you did want to use a list, it's quite good actually in terms of showing you everything, and then you can just add things together. So if I just put 1, 2, 3, 4, 5, and 6, and then press equals, and then put in the code, it tells me the probability for a 1, for a 2, for a 3, for a 4, for a 5, and for a 6. And you can see that's the one we wanted. If I wanted anything in here, I can just add up all of those. So for example, in the next one, find the probability of obtaining more tails than heads. As long as you can work out which one it is. So to get more tails than heads, and it's, it's got to be more. So the only way that can happen is if we get T is equal to 4, 5, or 6. So we can just add up 4, 5, and 6 from here. So 0.2 plus that plus that. So what is that? That's about 0.3 something. We just have to add all those up technically. I'm not going to do it this way, but that's the way that you could, in theory, do it. I'm going to do it the fact that I want the probability of T to be greater than or equal to 4. If I know that I want at least 4, then that's going to be 1 minus. I want 4, but I want to remove everything less than or equal to 3. So I'm going to find that on the calculator. So for that, I'm actually going to use the cumulative one. So number 1 down here, variable, and then I just want to put 3 into there. I'm going to do 1 minus 0.65625, which is equal to 0.34375. And that's the kind of final answer there. We can then, of course, round it and whatnot. Part D, the second coin is biased with such that the probability of obtaining the head is a quarter. This second coin is also spun 6 times. Why is it being spun and not flipped? Well, find the probability that for the second coin, the number of heads obtained is greater than or equal to the number of tails obtained. So this time we've got a slight different one. We're talking about heads here. So it's the same idea though. So heads is modeled binomially 6 times 0.5. So I'm just going to use the H instead now. Which heads is greater than or equal to. So in this case, I want P of H to be greater than or equal to 3, isn't it? So because I want 3, 4, 5, and 6. So technically, if I had that list again, I could just take off the probability of, I could add on the probability of 3 to this, or no, take it off in this case, and find that out, but it doesn't matter. So I want to do, let's have a quick look. I want to do 1 minus the probability that H is less than or equal to 2. Same kind of idea here, though. Good. Oh no, obtain a head because it's a bias coin, quarter. Oh, why don't I read things? Here, 0.25. Apologies. So I couldn't use that previous list. I'm just an idiot. So it's going to be 0.83, whatever that is. So 1 minus 0.830566, which is going to be 0.169, let's say 5. So 0.169, actually, it wouldn't round to 5, it'd round to 4, because it's going to be 4, 4. So we'll just do that. So it's going to be 4, 3, 4, technically. And that's it. That's that one. Again, there are other ways you could do it. If you want to do a manual calculation for each one, because you don't have this calculator, then you're using the formula from the formula book. I highly recommend just getting the class whiz if you don't already have it. I think most people have that though. Just again, going to swap out of that. Question 4. Number 4 is a great question to have, just with the distance or the velocity time graph here. So in part A, it's basically just saying describe what's happening to the travel direction of travel. Direction of travel just remains the same. It's constantly moving away. So the car travels in a positive direction throughout. A lot of people read this and think it's coming back home. It's not. If you start here, you're constantly traveling at a velocity. All that's happening here is you're getting further away. So if this was my starting point, this is where I start. I'm just going to do it on a kind of single track here. I'm speeding up. So my velocity is increasing here. I've got acceleration. Then I stay at a fixed kind of thing. So the first little bit, I'm getting faster and faster and faster. So I travel more distance and I stay at a fixed speed. Actually, I can't really represent this as a simple, just a time itself. But you're getting further away from home. You're staying further away from home. And then you're just slowing down. At no point do you turn back. So it stays, how do I say this? Travels in the same direction. In this case, I'm going to put positive because it's always a positive velocity. Part B, describe the motion of the car between O and A. I've just done that. It's accelerating, so it's increasing in velocity, therefore accelerating. If you work that out, you can do. So we do, it travels, it's 10 divided by in 5 seconds. So it's 2 meters per second squared. part 2 there between A and B, it's at a constant velocity, so 0 acceleration. So constant velocity, or simply 0 acceleration there. Part C, calculate the total distance traveled by the car. Just put in numbers on here. So from 0 to 25, this is 25. From 5 to 15, this is 10. And the height here is also 10. So it's just the area of a trapezium. Just remember, total distance on the velocity time is the area underneath. So we have area equals A plus B, so the parallel sides, divide by 2. So we're basically taking the average of those two sides and then timesing that by the distance between them. So this is going to be 35 times 5, which is 175. And that's it. If you're not sure how trapezium works, you can kind of model it on a isosceles trapezium. Do it yourself. If you basically to find the mean of these two, if you cut this down here exactly at the halfway point on an isosceles trapezium, this bit that you're cutting off that I've colored red will fit exactly here. Likewise on this side, you can do this for any trapezium as long as you cut it on the halfway point. Stick that there and you get a very nice rectangle. And of course, a rectangle is just base times height. So that's all you're doing here. And that helps me remember the formula, actually. I want to find the average of the two sides and then just times by the height of it. Question 5, particle of mass 5 kg is at rest under the action of these three forces. Find the values of the constant A and B. So if it's at rest, it is in equilibrium. If it's in equilibrium, then the resultant force is 0. So I know if I do 8 minus 2 plus AB plus A minus 1, then that's going to give me 0, 0 technically. I'm going to put 0, 0. It's technically just 0, but it's fine. So this is going to give me 8 plus 2A is 0. Or B minus 3. Wow. I was hoping for a simultaneous equation here. B minus 3 is also 0. So that implies that B is 3. And this one, A equals minus 4. So once you've got those two, that's 3 points in the bag. On to part B. The direction of the force F1 is reversed. So F1 becomes minus 8.2. So just swapping those round. Find the acceleration. So acceleration is F equals ma. So it's no longer at rest here. So we want the F, that's the force, is mass times acceleration. Also a vector here. So the mass itself, we're told, is 5. The force then, let's work that out first. Minus 8.2 plus AB, so that's minus 4, 3. And then lastly, minus 4, minus 1. Working that out, I've got minus 8 is minus 16. And then 5 minus 1 is 4. So minus 16, 4. Yeah, that's right. And then I want to make that equal to mass times acceleration. So minus 16, 4 is equal to 5 times by my acceleration vector. So all I'm going to do is divide everything by 5. So that implies acceleration is equal to, and then let's give it in vector form here, it says. Doesn't really matter too much, but minus 16 over 5 I plus 4 over 5 J. And that's it. Again, any questions, just let me know, and I will get back to you on those. Question 6, we have train pulling carriage. Okay, so I'm straight away looking at this. The bit that's already annoying me is the fact this is in tons. Not just tons, actually, kilonewtons as well. So big numbers all around. Okay, let's draw a quick picture. So I'm, as I say, I'm a very visual learner. So I'll start by drawing my train. I like the positive to be going to the right. So there's my train. It's got this shunt, which is basically just a way to connect it to its carriage. So in other words, just like a tow bar. The train itself is 12 tons. And this one is 6 tons. Now, remember 12 tons is 12,000 kg. And 6 tons is 6,000 kg. So coming down here, I've got 6,000 G, 12,000 G. Now, in this, we're not going to use those. It's just simply just on a fixed kind of line. The engine produces a driving force of 10,000 newtons. The resistance motion is 5,000 on the engine. So we've got kind of this frictional force. It's maybe not just friction. It could also be air resistance. There could be all kinds of things all packaged in there. And then on the carriage, it's 3,000. And then obviously on this shunt, we've got the fact that we've got these tensions kind of keeping this together. So that as the train pulls away, so it's pulling this one forward, but it's getting pulled back by the carriage itself. So the carriage feels this pull force, and the train itself feels, they both feel a pull force relative to each other. But the carriage is in the positive direction. The train feels like a pull backwards in the negative direction. And that's it. So we need to put all of this together. Technically, we'd have obviously our normal reactions as well because it's on a surface, but we don't need them for this question. So show that the train's accelerating at 1/9. So we need F equals ma. Please try and always tell me which direction you're doing this in. It'll help yourself as well. So I'm doing it in the positive direction. And that means I'm going to look at all forces to the right, take away forces to the left. One other thing that I do is I like to put on here that I'm doing this for the entire system. I'm not just doing it for the train. I'm not just doing it for the carriage. I'm doing it for the entire thing. So I've got 10,000 minus 8,000 is equal to a total mass, which is 18,000 times by the acceleration. So that gives me that the acceleration is equal to 2,000 divided by 18,000, which is 2/18, which is, of course, 1/9 meters per second squared. So that's that part. Part B, when the train is traveling at 30 meters per second, the shunt fails. Wowzers. Work out how long it takes the carriage to come to a halt. Okay, so the first thing I'm thinking here is, sure, we know it's at 30 meters per second. We'll get to that in a little bit. That to me right now is just basically sticking out in my head as U equals 30. So a starting kind of force is 30. It doesn't matter for now though. Let's have a think. Actually, could we just use that to find acceleration? No, we couldn't. Let's just have a think what's happening to my diagram. So for my diagram, everything's staying the same, I hope. We're not told here about resistance. So I'm going to assume that the resistance stays the same for both of these things. So this will stay at 3,000. If you read slightly further on, stay at one assumption. Well, I've just made a huge assumption there. The train has got 5,000. I'm not going to write everything in here, but it's lost its driving force. So there is no longer a driving force here. Technically speaking, then, without that driving force, what's really going to happen is it's going to start slowing down, which means it's going to start to decelerate. So these forces are technically going to be changed in a way. This carriage is going to feel that train, the weight of that, well, the mass of that train kind of pushing back on it, and it's going to also start to slow down. The train itself is going to feel the force from the carriage trying to go beyond it because it was going faster, but then they're slowing down at that same rate. So these forces are technically going to change. Doesn't make a difference for this diagram though. That side, it's all done, so we need to work out a new acceleration. I'm going to do it for the carriage because that's what we're dealing with. So for the carriage itself, the acceleration, so F equals ma, let's do it going forwards again. That gives me, wow, I've got, actually, let's do the entire system, can we? Oh, it's a shunt that's failed. Oh, what am I doing? Why can I not read? The entire question messed up again. Here we go. There's my diagram. The shunt's failed. The train's gone off on its own. The shunt's failed. Should be doing these videos at So late at night. Anyway, the carriage itself, this is the actual diagram, isn't it? So we've got the force itself, it's just minus 3,000, equals the mass is 6,000, and the acceleration is there. So that tells me that acceleration is equal to minus 0.5. And that's it. We got it. It's all good. So that's its new acceleration. Now we want to find out how long it takes the carriage to come to a halt. So using suvat, we don't have a distance. We do have this. We know it wants to come to a rest. We know its acceleration, and we want to find its time. So just going through all of that, we can see we're going to use v equals u plus at. And just putting those values. So 0 equals 30 minus 0.5t. And we're just going to rearrange that. So t is equal to, well, half t is equal to 30. So t is equal to 60. And it's in seconds, just going from, well, the fact that we're in meters per second is the hint there. Lastly, part C, the modeling assumption that I personally made was that the resistance to motion remains unchanged. We could say that it's going to decelerate at a constant rate, so there's no other kind of force affecting it. Trying to think if there's anything else there. That's probably it. That's the main assumptions that we've used there. I'm just trying to think if we could use things like air resistance, but it's all packaged into that 3,000 newtons. So basically the resistance to motion remains unchanged. Finally, number 7, a ball B moves along a straight line. B is initially at rest. At time t, the velocity is t1 minus t squared. Show that the maximum velocity of the ball is equal to this. Now, this is a little bit of a pain because it requires you to think a little bit pure like. You can use, if you've learned them already, the constant acceleration formulas. But as at this stage, you might not have got those. You're thinking a little bit about the pure mass that you've learned so far and seeing maximum. You've been told that your velocity is equal to t1 minus t squared. And right now, like this might help you see that the rate of change of velocity with respect to time, we can actually work that out. So this is t minus t cubed. So this one is going to be 1 minus 3t squared. The maximum occurs when that differential is 0. So 1 minus 3t squared equals 0. That implies that 3t squared is 1. So t squared is equal to a third. So t is equal to 1 over root 3, or root 3 over 3. That's going to be really important in just a second. I'm just going to add a little bit here. So the max implies this. From here, all you're doing is shoving it back into the velocity because you want it to find the maximum velocity. And then that's all we're kind of going for here. So velocity when t equals root 3 over 3, velocity itself. So remember, this is the maximum velocity is when it's at this time. So we differentiate velocity. So we're finding the maximum velocity. It takes place when t is equal to root 3 over 3. So we're just going to put that back in. So root 3 over 3 times by 1 minus root 3 over 3 squared. And we just kind of want to work that through. I think I'd have preferred to use this formula here. So I'm actually going to go straight into there. Like that. So in order to do this, I would keep this one the same. Minus, doing this one, it's going to be 3 root 3. So root 3 squared is 3. And we've still got the extra root 3. Divided by 3 cubed is 27. So what I'm going to do is change this to a 27 by timesing this by 9 at the top and 9 at the bottom. Like that. And 9 minus 3 is 6. So this is 6 root 3 over 27, which is equal to root 3 over, what's that going to be? It's going to be 2 root 3, isn't it? Over 9. And that's basically the answer. What we actually now need to do is times top and bottom. This is a little bit crazy here. I'll come back up here in a second and show you what I should have done. What I want to do here is simply times top and bottom by root 3. Just to unwind that. So I get 6 over 9 root 3. Ugh. And then finally, 6 and 9 both divided by 3. So that gives me 2 over 3 root 3. That's a crazy kind of way of doing that. What I should do, I'm not going to scrub it. Let's just leave that. What I should have done is actually use the fact that root 3 over 3 is the same as 1 over root 3. I should have left t as being this. It would have been much nicer if v equals 1 over root 3 minus, and then I'd have had, on this one, it'd been 1 over root 3 squared. No, cubed, sorry. 1 over root 3 is therefore minus 1 cubed is 1. Root 3 cubed, we said, is 3 root 3. Times top and bottom here by 3 gives us 3 over 3 root 3 minus 1 over 3 root 3, which is 2 over. That's the way I should have done that. But again, you've got a calculator. I've done that on non-calculator. It's not too bad when you see that you're dealing with differentials because it's a maximum. If you didn't miss that, it's an easy 5 marks to lose. Well, apologies. Hope that helps. If there's any questions, just let me know and I'll get back to you as soon as I can. Thank you.